Hello viewers, welcome to this video. In this video, you are going to learn page replacement algorithm. One of the page replacement algorithm which is first in first out. So which is used for managing the memory in your operating system effectively. So from this video, you are going to learn what is when we page replacement and why it is required, and what are the available page replacement algorithms, and we are also going to see about uh, one basic algorithm which is first in first out page replacement algorithm with some example. So first let me tell you what is meant by page replacement. So you could be aware that any process to be executed should be available in main memory. So actually any process which is not to be executed will be residing in secondary memory, that is hard disk. So only if it is necessary to be executed, then it will be brought up into the main memory and then it will be executed. So that is the actual scenario. So here, in order to manage the memory effectively, the operating system has introduced a concept called paging. That is, the entire process will be divided into number of pages. So only the necessary pages will be brought up into the main memory so that the main memory can be effectively utilized. So in this situation, there might be a scenario where a page is required to be executed, but it may not be in the main memory. So in this situation, already some of the pages will be residing in the main memory. So the required page, if it is to be brought up from secondary memory to the main memory, then we have to move any one of the page that is already available in the main memory out of the memory queue. Only then the currently required page can be inserted into the main memory queue. So in order to implement this, we have a concept called page replacement. That is, remove the existing page from the main memory queue and then bring the required page into the main memory queue. So that's what called as page replacement. Replacing a page from the main memory by a page from secondary memory. So why it is required? So whenever a page is required to be executed, so if that particular page is not available in main memory, then we will encounter a situation called page fault. That is, page is not available in the main memory. So that is called as page fault. So to handle the page fault effectively, so we have a concept called page replacement. So whenever the requested page is not available in main memory, we will encounter a situation page fault. So if page fault occurs, then obviously the application will not be executed successfully. So in order to execute any application successfully, we need to handle this page fault. That is, the operating system needs to handle the page fault. So that's why there's a concept introduced which is called as page replacement. So there are three popular page replacement algorithms. One is first in first out. The next is optimal page replacement, and the last one is least recently used. So any of these algorithms can be used in order to manage the main memory effectively. So let us consider the first algorithm, first in first out. That is, whichever page has been allocated a frame for the first time. So that particular page can be removed if any other newly arrived page comes. First in, first out. Whichever page is given or allocated frame first, then that page can be removed in future when any new reference comes. So consider this reference string 70123030. So that is, this is the these are the page numbers, and also it represents the order by which the pages are referred. So first it refers to the page 7. So in this case, you consider the number of frames assigned for each processor, 3 frames. So which means that at any point of time, 3 pages can be in main memory. But if you see here in the reference string, there are more number of pages. So in this case, definitely there will be page fault. So let us see how this FIFO algorithm handles the page fault. So how it reduces the page fault. So first page number 7 is referred. Initially the frames will be empty. Okay. So you have 3 frames for the process. So initially it will be empty. So which means there are no pages in the frame. So now the page number 7 is referred. So in the frame there is no page. So in this at this point of time, a page fault will occur. Okay, since there is no page number 7 is not in the frame of the physical memory, so page fault will occur. So it is one page fault. Then page number 0 is referred. Again, it is not in the physical frame. So another page fault occurs. So it is second. Then page number 1 is referred. So again, it is also not in the frame. So again, another page fault occurs. So totally, as of now, 3 page faults has occurred. So now the pages 7, 0 and 1 are put into the frame. So now there are no free frames available. So let us see what happens when other pages are referred. So another page is referred, which is page number 2, but it is not in the frame. Okay, so it is not in any of the frames, and also there is no free frame available. So in this case, what this FIFO algorithm will do is that it will look which one has been put into the physical memory first. So page 7 has occupied the physical memory first. So it removes the page number 7 and then it puts this page into the backing store. Then brings the page 2 in place of page 7. So now the frame see the pages in the frames 2, 0, 1. So let us consider the next page 0. Okay. So 0 is already in the frame. So no page fault occurs. Okay. So as of now, 4 page faults has occurred. Now next reference is page number 3. So 3 is not in memory. So it has to decide which page to pull out from the frame and then put it in the backing store. So here among the pages 2, 0 and 1. So 2 has occupied the memory now only. Okay. So if you consider 0 and 1, among 0 and 1, 0 has occupied the main memory earlier. So 0 is removed from the frame and then put in backing store. Then 3 occupies the place of 0. So now the frames, pages in the frames are 2, 3 and 1. So now consider the next reference. So page 0 is referred. So again, 0 is not in main memory, another page fault. So again, it has to decide among the pages 2, 3 and 1 which one to be replaced. So 1 is brought in memory earlier among these 3. So 1 is removed and then 0 occupies the place of 1. So 2, 3, 0. Now consider the page number 4. Again, it is not in memory, so page fault occurs. So among pages 2, 3, 0, 2 has been brought into the main memory earlier. Okay, because 0 has occupied now only. So among 2, 3, 0, 2 has occupied the memory earlier. That is first. Okay, so that is the order. So 4 2 has been replaced by 4. So now the pages are 4, 3, 0. So next reference is 2. Again 2 is not in main memory. So now if you consider 430, 4 has arrived now as the latest page. So if you consider 3 and 0, 3 is occupied earlier. So 3 is replaced by 2. So 420. Then again page 3 is reference. So if you consider this into the frame, so you have only pages 4, 2 and 0. Page 3 is not there. So again another page fault occurs. So among 4, 2, 0, 0 has arrived earlier. So it removes 0 and then places 3 into that particular frame. So now the pages are 4, 2 and 3. Okay. Again now 0 arrives. So a reference for 0, page number 0 is made. So again among there is no such page in the frame. So again page replacement occurs. So where when you consider 4, 2 and 3, 4 has arrived earlier. So it removes page number 4 and then places 0 there. So now the pages are 0, 2 and 3. Then again 3 is so again 3 is referred. So 3 is already there. So no page fault. Then 2, page number 2 is referred. So 2 is also there. So no page fault occurs. So now next reference is page number 1. So it is not in the main memory. So what happens? Among 0, 2 and 3, 2 has occupied the memory earlier. So it is replaced by page number 1. Okay. So 0, 1, 2. So now, sorry, 0, 1, 3. So now again page number 2 is referred, which is not in memory. So now among these 3 pages, 0, 1 and 3. So 3 has come first. So it removes page number 3 and puts the page 2 into that particular frame. So next reference is 0. So it is already in memory, no page fault occurs. Then next is 1. So 1 is also there. So no page fault occurs. The next reference is page number 7. It is not in the memory. So 0 among 0, 1 and 2, 0 has come first. So it removes the page number 0 and then replaces it by 7. So 7, 1, 2. Then consider the next reference, page reference is 0. So again it is not in memory. It is, so again page fault occurs. So here among 7, 1 and 2, 7 is arrived now only. So it considers 1 and 2. Among these two, 1 has come first. So it replaces 1 with 0. So now the pages are 7, 0 and 2. Again page number 1 arrives. So it is not in memory. Again another page fault occurs. So among these 3 pages, 2 is the is one which has arrived earlier. So it replaces 2 by 1. So totally if you count the number of page faults, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 page faults has occurred. Okay. So this is for this particular reference string. Okay. So if we have less number of pages, even less number of pages also can cause more page faults because it is based on the page number which has been referred. Okay. So this is an example. Let me show you another example for the same one. So this one is a very simple example. So this is the FIFO algorithm example. You consider this reference string 13035663. Okay, and then consider the same number of frames that has been allocated. This the number of frames allocated for this processor three. Okay, so three frames are allocated. So consider this reference string. So if you consider the first page, it is initially I said that the frames will be empty. So page number one is referred now. So it is not in main memory. So it is put into the frame. Wait a minute. So here it is put in from the bottom. You consider the, please don't confuse. So if you consider one, it is put first. So it occupies the first frame. Then, so for this first page, a page fault occurs. Then you consider the second reference string, that is page number three. So again, it is not in main memory. So it occupies the next place. Then, so again here page fault occurs. Then for the next reference, it is page 0. It is not in memory. So it occupies the free frame. So now the pages are 130. So as of now, three page faults has occurred. Then again, if you consider the next reference, it is page 3. So it is already in memory. Okay. So no page fault occurs here. So that's why they have mentioned it as hit. Miss means that page fault. Hit means that there is no page fault. So next one is 5. So 5 is not there in the frame. So now free frames are also not there. So now it has to replace the page. So select a victim page. So as far as FIFO algorithm is concerned, it will be replacing a page which has been brought up first. So in this case, page 1 has brought up into the physical memory first. So it will be replaced by the newly referenced page 5. So now the pages are 0, 3 and 5. You can, so here again a page fault occurs because 5 is not in memory. So 1 is replaced by 5. So 4 page faults. Then you consider the next referencing, which is page 6. Again it is not in memory. So among 0, 3 and 5, 3 is 3 has come into memory first. So 3 is replaced by 6. So again, it is a page fault. So the number of page faults is 5. Then you consider the next string 3. Again, it is not there. So among 0, 6 and 5, 0 has arrived earlier. So it replaces 0 with 3. So now the again in this case also page fault occurs. So totally 6 page faults. The reference string is only 7, but you consider the number of page faults. So it is 6. I think you could have understood how the FIFO algorithm works. So in the next video, I will introduce you to another algorithm, which is optimal page replacement algorithm. Thank you for watching this video.